Welcome back to all of you in Physics की दृष्टि. Welcome in our important question series. And today we will discuss B.Tech Engineering Physics important question. And this is the last unit, unit number 5. And that name is what? Nanomaterials. This is our very important question. And I will guarantee you 100% this question will reflect in your end semester paper. So let's start, and this question carries 6 marks. That means 6 marks important questions. So let's discuss today's most important questions. That name is, or the question is, define the nanomaterials. First of all, define the nanomaterials. What is nanomaterial? And then discuss how physical, thermal, mechanical, electrical, optical, and some another properties of low dimension materials, or we can say how they are changed when bulk to nanomaterial. So this is a very important question regarding our NSEM examination point of view. And I think 100% this question will reflect in your end semester paper. So let's start with the definition. First of all, define nanomaterial. So what is nanomaterial? So this is the definition of nanomaterial. Nanomaterials are materials in which at least one dimension is less than approximately 100 nanometers. So whatever material we have, that material at least one dimension, that means length, breadth or height, anyone can be in a approximately 100 nanometer, and we already know 1 nanometer, that means how much? 10 to power minus 9 meter. So if it is nearly 100 nanometer or less than that, then that material is known as a nanomaterial. So nanomaterials are commonly defined as a material with average grain size is less than 100 nanometers. So this is the definition of nanomaterial. You can write down some example also if you have a waste like a full range or buckyballs or that kind of things. A nanomaterial is a 1 millionth of millimeter, and approximately how much it is? 1 lakh times smaller than the diameter of the human hair. So this is one of the another example. How much nano is? So nanometer is a 1 millionth part of the millimeter. We already know very small, 1 millimeter, first division in our compass scale. So it is a 1 millionth part of your millimeter, or we can say approximately 1 lakh times smaller than the diameter of our human hair. So this is all about the nanomaterial, and now one by one we will discuss its physical, mechanical, thermal, electrical and optical properties. So let's start. In your examination they will ask any 4 or 5 properties. They will ask write down physical properties, mechanical, thermal, electrical, optical and magnetical. So let's discuss one by one. These is our very important question. Again I will tell you, the question has 6 marks. Okay, so let's start. Our first thing is physical properties. So only one thing is required in physical property: surface to volume ratio. And in nanomaterial, surface area to volume ratio is very large. Only remember this one line. In a nanomaterial, surface to volume ratio is how much? Very high. Just take one example. Suppose your nanomaterial shape is a sphere. So surface, so what is the surface of sphere? 4 pi r square, and divided by volume 4 by 3 pi r cube. So 4 cancel, pi cancel, r square cancel, remaining is only 3 by r. Suppose whenever you are putting the value r, suppose r is your 1 centimeter, so the ratio is 3 by 1, only 1, sorry, 3 by 1, that means 3 centimeter. But whenever your r is 1 nanometer, that means 3 divided by 10 to power minus 9, the ratio is 10 to power plus 9. The ratio is very large. Got the idea? So as the size or shape decreases, जैसे जैसे वो shape कम हो जाता है, वैसे surface area to volume ratio is increasing. So whenever size is decreasing, surface by volume ratio is increasing in a manner. This is all about the physical property. And you can write also, whenever reducing size of the particle, what happen? The density of states become more quantized, the band gap shift towards to higher energy, and the absorption spectrum going towards to blue shift. I will explain this sentence in our fourth properties, how it will going towards to blue shift. Got the idea? So this is our first property. Now second one name is mechanical property, and in mechanical property there are two subpoints. First, elasticity. So what is elasticity? I think already know. Elasticity characterize the ability of material to resist elastic deformation, that is stiffness. The relationship between stress and strain is, everyone know, stress is proportional to strain, and just remove this proportionality sign. Y is what? Young modulus. So in a simple, stress is proportional to strain. That means you got a very linear line here. But in case of nanomaterial, what is the different thing? The elastic relationship is non-linear. This is the main point. The elastic relationship is non-linear due to non-linear surface effect. These one line is enough for your explanation of the elastic property. And the second sub point of the mechanical property is, this one is the second one, hardness and ductility. Simply the hardness and ductility relationship, that name is Hall Page relation. You can write down these equation also, but how to explain in your exam? So whenever, say very simple, whenever size is decreasing, suppose here the size is decreasing in this direction, what happen? Always hardness is increasing in a manner due to the grain sizes decreasing in the manner. That's why they are writing, as a grain size in the nano region, हार्डनेस इंक्रीजेस विथ डिक्रीजिंग द ग्रेन साइज. जैसे 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 आप पार्टिकल का जो ग्रेन साइज है वो कम करते जाओगे, whenever grain size is decreasing, hardness is increasing in the manner. And how much it will be increased? It can be a 2 to 7 times harder for the pure nanostructure material. That means suppose I have a metal material, which one is the strongest? Iron. Fe is the hardest material, but whenever I am talking about nanomaterial, it is more harder compared to Fe. And how much it is? 2 to 7 times more harder. And the size is 10 nanometer grain size. So very high hardness we have whenever we have a very small grain size. And similarly, large increase in a yield stress, nanocrystalline material with size reduction suggested that feature stress can be lower than yield stress, and therefore the result is reduced ductility. So this is your result. Got the idea? Next point, third point, thermal properties. And in thermal properties, there are four subpoints. The first point is melting point. 4 points are very simple. See, every time just compare with the scale. Suppose this is your graph. Just whenever we decreasing the grain size, you can see 20 to 15, 10 and 5. Whenever we decreasing the size, what happen? This is the graph of melting point. Melting point is decreasing, 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 decreasing. So very simple. Whenever, see, the statement is what? The melting point of nano gold particle. We are talking about nano gold particle decreases from 1200 Kelvin to 800 Kelvin. So suppose this is the value of 1200 Kelvin. So whatever melting point nano gold have, okay, and it will be directly decreased to shear, that is 800 Kelvin. When the size of particle decreases from 300 angstrom to 200 angstrom. So suppose this is the size and that size is 300 angstrom. So its melting point is how much? 1200 Kelvin. But whenever the size is little bit low, 200 angstrom, then the melting point is decreasing and directly it is near to 800 Kelvin. So there is a one line, whenever we decreasing the grain size, the melting point is decreasing in a manner. Second subpoint is thermal conductivity. Similarly, whenever we decreasing the grain size, the thermal conductivity is also decreasing according to this graph. So you can write thermal conductivity reduce with the particle size. जैसे जैसे साइज कम करते जाओगे, थर्मल कंडक्टिविटी भी कम होती जाएगी. Third sub point in the thermal specific heat. So in the specific heat, it can be a little bit inverse. How? whenever we decreasing the grain size, see, whenever we decreasing the size, what happen? The specific heat is increasing in a manner. Okay, so that's why they are writing the specific heat is inversely related to grain size. That means what? Suppose this is your grain size is decreasing, then it is inversely related, that means specific heat is increasing in a manner. And similarly, the fourth sub point is thermal expansion, and it is similarly, whenever grain size is decreasing, thermal expansion is also increasing in a manner. And that's why you can write it is since that thermal expansion coefficient increases with decreasing the grain size. It will be increases when the size is decreasing in the grain size. In the examination, very rough graph is allowed. Suppose for thermal expansion you can draw like this, for this you can draw like this, all things are not needed. So the examiner have some idea, okay, the graph is here, this line is there, that means you know whatever content we have. Got the idea? So this is all about our third point, thermal properties. Fourth point, electrical properties, very easy point, only 2 points are required. Everyone know in bulk material some free electrons are there. But what about the nanoscale or nanoconductors? There are two different effects we have. First effect is quantum effect. What happen? Continuous, that means nearly bonds are replaced with the discrete energy level. See, in bulk material na continuous bands are there, but in quantum effect the energy levels are discrete in the nature. And the second thing is classical effect, that means mean free path in elastic scattering become comparable to the size of system. So this is our second effect. And you can write also in the electrical property what is the main thing. In nano ceramic and nanomagnetic composite, the electrical conductivity increases with reducing the particle size. This is the also main statement for this our property, and rest of the things you already know. In a semiconductor, quantum confinement and both electron and hole leads to increase the effective band, and that's why material with decrease in the crystalline size, the effect leads to conductivity in nanomaterial. This is the same reason responsible due to its discrete energy level. That's why that name is what? That another idea is all about quantum confinement. Got the idea? Next, fifth optical property, how it look like. See, suppose this is the bulk material, not in bulk, but see, the energy levels are very near here. But whenever we are decreasing the size, see, the energy levels are discrete, not continuous. See, again increase it, see, they are discrete, not continuous. So what happen? Ultimately, whatever your band gap is increasing in a manner. Okay, and what happen? See, AU thin film 10 nanometer thickness become partially transparent. See, how much? 10 nanometer. So whatever we have a thin film, so AU is a gold. Gold is not a transparent material in bulk, but whenever we are dealing with nano, na, it become partially transparent. And again, just check, these all materials are chemically same, but only the change is what? Size. The size of atoms or whatever molecule, that nearly 6 nanometer, just decrease it, decrease it, decrease it, decrease it. At the end, this size is 2 nanometer. So its color can change. Its color will be changed because of its size. Otherwise, chemically they all are same. So at the end, whenever we decrease the size, at the end color is going towards to blue, and that's why it's called as blue shift. Got the idea? So let's conclude it. At a very small size, metal nanoparticles can develop a band gap due to the discrete energy levels, and the semiconductor quantum dots or optical absorption and emission shift going towards to blue shift, the size of the dots decreasing. जैसे जैसे आप कम करते जाओगे वो blue shift की तरफ जाएगा. The absorption spectrum showing a blue shift also. Got the idea? And that name is what? That name is quantum confinement. And due to the quantum confinement, what happened? The energy levels are discrete, not continuous. Got the idea? Last but not the least, sixth point, magnetic properties. So whenever we are going from bulk to nano, some magnetic properties is accepted change significantly. How? Check the first one. the ferromagnetic particles becoming single domain. Second, supermagnetism is a small ferromagnetic particles. Third, giant magnetoresist effect in a hybrid. Fourth, anti-ferromagnetic particle in bulk behaving like ferromagnetics. So just write down some example. These are the possibles when we are going from bulk to nano. And you can write some another thing. There is a increase in a magnetic moment as well, decreasing dimensionally of the system. Increase in magnetic moment वो बढ़ जाएगा कब? When we decrease the dimensionality of the system. And you can write some example also. Suppose this is our first example. Transition metals are ferromagnetic in bulk. The transition metals are how behaves ferromagnetic in bulk, but they exhibit the super paramagnetism in a nanophase. The another example, very common example, sodium, potassium, ruhedium are paramagnetic in bulk, but they are ferromagnetic in a nanophase. You can write third last example, this one also. So this is all about the magnetic property. Got the idea? So just write down this six property, or just remember this six property. You got 6 out of 6 marks. And suppose examiner asked any four, so just write down any four. Not required, not mandatory to write all of 6 properties. Okay, so whatever asked in your examination, write those property. If they are asking physical, then optical or magnetical or mechanical, whatever they are asking, so write down this four. If they are asking 6 out of 6 property, then write all these properties. So you got 6 out of 6 marks. And thank you very much to all to provide this type of support of our channel Physics Ki Drishti. And just remember, this is 100%, this question will reflect in your question paper, properties of nano material. So always remember this 6 property, and you got 6 out of 6 marks from this chapter. Thank you very much to all. Subscribe, like, share, and subscribe this channel. And just only one video is remaining for a numerical problem. Okay, so for your numerical, there are two different numerical in your exam paper. We will solve together. Okay, so we will meet after some times. Thank you very much to all. Thank you very much.